Here we have a function, 4 sine x plus 3, and it wants us to find the antiderivative. Okay, well, this can be a little tricky. Here's what I do for derivatives. I just remember the derivatives well. Derivative of sine is cosine, and the derivative of cosine is negative sine. So I just know the derivatives really well, and then I just think the antiderivative is backwards. So in other words, I just remember the derivative of every cofunction is negative. Cosine, cotangent, cosecant, all of them are negative. So go back here and go, okay, I want to do the antiderivative. And so then I think, okay, it maybe it's got to be 4 cosine or negative 4 cosine. It's either a plus or a minus out there. How do I know which one? Well, I just look at it for a minute and think about doing the derivative and ask, would it go back? If I leave it plus, will it work? Derivative of cosine would go back to negative sine. Oh, that'd be wrong because I remember that the derivative of all cofunctions is negative. So it can't be plus 4 cosine because the derivative would go back to negative and it never was negative. Oh, so it must be negative 4 cosine because then when you take the derivative of negative 4 cosine, derivative of of cosine will be negative sine, and then the two negatives will go back to plus. Ah, that's right. And then the other part, what about the plus 3, the anti for that? It's just 3x, right? Because the derivative of 3x will go back to 3. So for antiderivatives, I just always write something down and then I look at the derivative to make sure it goes back. See how I'm always doing that? Derivative of 3x will go back to 3. Derivative of minus 4 cosine, any co is negative, so another negative, two negatives, positive 4 sine. So there's the antiderivative, which is exactly what they got. Plus a c, plus a constant. So there we go.